Okay, getting started with our data analysis, our Bootcamp 8, the Python section. I'm going to go over how to use Plotly. Okay, so getting started with our standard data science libraries. And here we have Plotly.express as PX. Okay, we're going to use the US honey production data set today and looking over the honey production in the US states over, I think, 7 years. Good way to get started is just looking at the data types here. So getting rid of .info or looking at .info here to understand those data types. Okay, and we have mostly numeric ones with a couple objects. The EDA, I'm gonna make we have mostly numeric values. I wanted some categories to be able to play around with today in our data analysis. So I did some bins right here, just using pd.cut, but we're experts at that now, and putting in 4 outside labels for 3 bins. Okay, and then also making one for yield per colony. Going to do this one just into 2, 25, 60, 135, low and high. So 3 outside edges and 2 bins. Okay, and making both of those. Let me make sure I'm running these. Ooh, can't put extra letters there. There we go. And make sure that turned out right. There we go. And then here we're doing yield per colony. Okay, so getting into the 1D analysis or one-dimensional analysis, univariate analysis with Plotly. Okay, so the way that I like to use Plotly, especially when I do more than one plot, I like to set up a little kind of parameter, hyperparameters for my model. And so here I'm doing the width and height. The way that we control width and height is very different. So this is kind of the first time that you'll get this experience, is that all the visualization libraries that we've dealt with up until now have been based on matplotlib. So they all have this very similar syntax. You might not have realized how similar it was. Plotly is not. So Plotly is made with a completely different engine that they built from the ground up. Okay, so we set the width. This is by pixels, not by the inches that's available in, depends on your screen size, inches on matplotlib, the height and the figure size, and then putting that parentheses 4 by 3 or something like that, 5 by 4. This is a little bit, there's a difference of width and height. Okay, and we're also going to control the marginal dictionary. This is going to be, or sorry, the margins on the outside. I feel like it just leaves a lot of white space by default. So let's see what this looks like. Let's run this without these. Turn off this one as well. It comes up really big by default. I find it maybe doesn't happen on your monitor, but it just takes up all of the space. So by setting the height and width, looks a little better sizing. Then you get the figure update layouts right here, and you get just a little bit less white space on the outside. I think you'll find this helps, especially when you have the legend, a title and stuff. This makes this a little bit cleaner and stuff. Okay, so we first make the histogram right here, px.histogram, width and height right here, df. So we give it it works well with pandas. Give it our data frame and then just the x value. Okay, we're going to save this as a figure, and then the next one we'll go fig.update layout margin equals margin dic. Okay, and then fig.show. Okay, so a little bit different, but not super different from what we're used to with Seaborn, pandas. This update layout is something that I use all the time, almost after every single one. So this is a little bit different, but it's not that hard to get used to. Okay, but we can do lots of the same things in Plotly as we could with pandas, Seaborn. Okay, so here we can do the number of bins here. We're controlling the bins, so 30 bins, px.history with height. Then we're doing the margin dics here, so just adding more bins in. And you can see with a few more of these. Okay, just getting some more texture right there. Okay, next I'm looking at we're going to change the color by the year bin that we created. And so now just like the hue argument in Seaborn, we can now change, we can do the same thing, but it's now called, instead of hue, it's the color. Okay, so change the color by a category. Here, where we're doing in the next one, we're going to change the y now value is going to be what we're going to put inside of the bin, and then hist function is going to be the average. Okay, so we're going to use that, the average of the yield per colony bin to fill up the average. And you can just see how different this looks now. Because it's not really about the data. It's a lot more uniform. We can see now that the yield per colony is more consistent across the distribution than it is the actual amount of values that we have in average price. Okay. So the yield was roughly the same per colony. It didn't change. That's kind of interesting. It didn't change regardless of the price. The yield per colony was roughly fairly consistent, which is kind of interesting. Something you wouldn't be able to see in any other way. Okay. Or well, easily see in any other way. Okay. So just having a little bit more fun with this. We're going to change the pattern shape, pattern underscore shape to yield per colony bin. And now we're really, can be really busy when you start to play around with the patterns and the colors together. But now we can visualize this and really, we can unselect. So if we want to look at only the high values, putting those here, but maybe we want to look at the low value with this as well. Okay. So it starts to give us a really good sense of how this works. This relationship, and really you're factoring in two categories now, how it's impacting the distribution. It can be pretty busy, but you can really get right down into it. And the cool thing about this is we can kind of zoom in on any given, I want to really understand how much, what are the levels right here? But we don't even need to zoom in because we have the interactivity that's going to highlight exactly how much each one of these areas are, each one of the patterns, which makes this, even if it gets a little bit busy, it's still usable. Okay. So we can also add the marginal equals box and adding the box plot on the margin. And this is, I love this, just that it's able to highlight then these regions right here. So you can see the fence goes from 585. And it's just really valuable in that sense. We get a good sense of the data here, and then you can kind of select, deselect, and really focus on, I want to look at these two. I want to look at these two. What's going on with these ones over here, right here? Okay, so it's really interesting to get an understanding of for your plots. You can also go over the marginal, adding text right here. I turn off the patterns, it gets a little bit busy, but here doing text auto equals true, just putting in the text values from this data set, so you can actually fill it up and really see what the value is right on it. Be again a little bit busy, but it could be nice to highlight and really put into a presentation. Okay. Violin plot here, getting into next. So as we talked about in Seaborn, it is showing the kernel density estimation plot on either side, and that is supposed to be better for human eyes to see. I liked about Seaborn, we could use the plot in individual categories distribution on each side, the class in each category. It worked well in a bivariate situation. Here, we don't have that exact same ability. We have another way to really inspect the difference a category is making on the distribution. Okay, so what we can add to this plot, we can add the box equals true, just adding the box right on side the violin plot, which I think is kind of nice just by itself. We can also notice here, so the way that we'd add in a title, we could start adding in a title right in the violin plot right here. Okay, and it just shows if we put it in the PX violin, it goes right here to the left side, which I don't really love. So a better way to do that is to actually put it here in the title right here in the update layouts right here. So just notice that first I'm going to do title X 0.5, so it's right in the middle, 50%. It still feels a little bit close to the top to me, so what I'm going to do is 0.95, kind of just move it down a little bit. You could do 0.55 and put it right in the middle of your plot if you wanted to, I guess. That doesn't really have any practical, but it could be kind of a nice little effect one time. So you have a little bit more challenging, not challenging, I guess, but to get it right where you want it, you have more flexibility. In Plotly, it's maybe not as default, it goes right in the middle and the center, but you can kind of play around with it now and you have more flexibility to kind of customize that to how you would like it. Okay. Another cool feature that we can do in the is, and we have this available in actually lots of the plots, is this hover underscore data. If you go df.com, so I'm going to say I want to see everything in this plot. So the cool thing about this now is I can go to any one of these visible plots, and I'm actually just turning on as well points equals all. Okay, so I'm just putting that, and it's putting the points. It looks like a swarm plot. It's more maybe a strip plot on the sides right here, but you can get a good sense of the actual distribution of what data is supporting this violin plot. So this is one little outlier right over here. We can go zoom in and see what's going on with this guy, and we can get a full understanding of what is occurring in that observation now. Okay, so it's really valuable in that plot, and we can get a lot good understanding. And if you just want to reset it, you just hit this house right here, reset axis, and you go back to the standard plots. Okay, so we can change one other thing is the violin mode equals overlay, and so we're going to put them on top of each other. And you can really start to really notice the subtle differences between the distributions and really get an understanding that you wouldn't be able to do it any other way. And then having these, being able to see that it's from this class that was the highest, okay, from this year. Really doesn't look like any of the green years made it up here to the very top, right? So you're not seeing any green up here. There's somewhere down here. What's the highest green right up here? That was, it was 18, and it was Hawaii. So Hawaii was kind of the number 1 and 2 regions right here, Hawaii as well. So look how much extra exploration that I just did without having to go to my data frame. It's kind of really valuable in time saving in a sense. Although maybe it's a little bit more coding to do. If you set it up properly with the margin dict and the height and width and stuff, it's a lot easier to use each time as you go through this. Okay, saves a little bit of coding each time. Okay, so of a whole, these are kind of categorical plots is the way that I would describe them. So we're looking for proportions of a whole, although we can use continuous variables throughout much of these as well. Okay, so px.sunburst, I'm going to do figure, and then I'm going to do df, I'm going to do path. Okay, so this is going to be starting from the center and then moving to the outside of the ring. So I'm going to start with the year bin, then yield per colony, then the state. Right here, you can start to see there's too many states in this, and just because to be on the last one, it makes it quite busy. Okay, so maybe that's not the best one to use here, but the cool thing is that we can go into one of the year bins and then even into the yield per colony bins and get a good sense of this. You can see much better now that really Alabama is the most occurring in this one, and then Wyoming is the least occurring, right? So you can get a good sense of the plot and then go further and really kind of enable that analysis right in this moment. Okay, and then putting my margin dict title, title X and title Y. Okay. Okay, so in the states here, or showing this another way to reduce this, is not really usable. So if I could only look at 5 states, the most occurring that would be valuable, what I'm going to do is just value counts. This gives me a list of the count of the values, but if I just want the index, it's going to give me the actual classes that appeared in this data set. And if I just grab the first 5, it's the ones that occurred the most in the data set. The first 5 then, so going from 0 up to 5, but not including 5. So 0, 1, 2, 3, 4, and you get those states. Okay, so I'm just then going to select logically indexing is in my list of states. Okay, and then going to select that from the column right there, and that will give me the ability to only look at the 5 most occurring states in this, and you can see it works out a lot better. It's a lot more visually pleasing in this sense. You can see not really any of them occurred in the lowest one. Okay, so value, average, width, height, margin, title, X and Y. So nothing really too different. It allows you to go get a little bit higher and understand. Really, only New York was in the high production, high yield per colony in this year. Okay, in 2014, so it's kind of interesting. And then all these other ones are in the low, only high and low in this sense. And so you can really see quite a bit more in low, and really New Jersey makes a very substantial portion of all of that. Okay, so very good. And just noticing here, I'm changing the values to be the average price versus the count of the values. It's now the average price. You can see New Jersey is able to claim a much higher average price than say Arizona. Okay, just based on the size of these proportions. New York is able to claim although average high prices, there's no one else in that sub category. But really seeing in the low version here, you can see that New Jersey is again able to capture the highest average price. Okay, so it's kind of interesting. And then Arizona the lowest. I don't know why that is, but it's substantially different. Okay, so it's kind of cool that you're able to then change what you're filling up this bin with as well. What goes into your categories in the sunburst plot. Okay. So doing a little bit more, just playing with the color here. Gonna continuous color scale equals red, blue. Play around with that. It gives you different effect. It can be quite nice in plots. And then getting into the tree map plot. Okay, so this you can do a lot with as well. So we're going to set the path again, year bin, and then yield per colony. And you can see here now I have my years on the outside, and then on the inside I have, you can look at now and see the height and the, or sorry, the high and the low of the production. So what generally category do they fall in? Okay. And then the values, what's filling up my bin here is the value of my production, right? So you can see that's what's making the size of the bin. High yield per colony is obviously has more value in production right here. Is what you're seeing. I don't think any of these ones, low does here, right? So they're low yield per yield per colony. They actually have more production overall here in 2018. This most recent year, kind of like gotta wonder what's happening to those bees, right? And really, they're not producing as much now. It kind of seems evident in this value here, where you see the high was actually a bigger portion of the value production, whereas this switched in 2018 to 2021. Okay, have a little bit more fun with that. So year bin, adding more in now the year and then the state. So we can go now and see 2018. Actually, go in and see what year is causing these. So let's go see who was in 2021. Okay, so North Dakota had the biggest value of their production. Minnesota, not so much. Wisconsin, not so much. Was this last one right here? Kansas and 800. So even though things are small with this interactivity, you have a lot of ability to go back. And if you want to go right back again at this kind of blank spot right here and kind of go look at the other ones, let's go look at the high production in 2010 to 2013. And you can see in North Dakota, it really kind of conquered it all of the years, right? Let's go see if it's still at the king of honey, and you can see North Dakota still, not so much in 2019. Okay, 2018. Oh, North Dakota, yes, it's a high production state, so it's all in right here. The top, if we want to go into the high production right here, okay, or yield per colony is high. Okay, and you can see it just dominates these ones as well, still in the current year. Very interesting analysis that we were able to do very quickly there without having to go back to the data frame. Okay, having a little bit more fun with this. Again, you can display a lot of categories in this. I think this is quite nice. You can put the states in right here and put all the states as the category. And it just, again, it makes it to be quite busy in some senses, but with that interactivity, we could still do a lot with this. And then here, just kind of having a little bit more fun with this, go in state and then yield per colony. Now you can go in really South Dakota or North Dakota, you can see is always high value. The high right here, South Dakota as well. Florida produces a lot of value production, but they are in the low yield per colony producers. It's interesting. You would think Florida would be in the high. Okay, so that's really nice, and just a lot of you can do with that of a whole plots, the sunburst and the tree map. Very, very unique to Plotly. Seaborn should have things like this, truthfully. Okay. The density heat map plot now, looking at this. So this allows us to do really heat map, very similar to what we did in Seaborn. And then here just doing X and Y though, not really putting in a correlation matrix in this. I find that works. It's just a little bit more valuable to actually inspect the X and the Y, a bivariate, true bivariate relationship. You can control the number of bins on the X and the Y. So you can see, and it's kind of nice that you can do this. I think really makes it pop and kind of unique is when we add in the marginal X and the marginal Y and able to control what we're seeing on each axis. We're also able to make subplots. So we could do faucet coal. So the column is going to be then the states. And I'm just selecting the top 5 states. And you can see really how the states are really changing now, right? You can see over the years, they seem to be getting down and dropping quite a bit, okay? Whereas, well, they're all kind of actually on downwards. I would say, though, that New York has been fairly consistent, and then North Dakota as well is fairly, or North Carolina is fairly consistent, although it did drop from a really high yield per colony in this 2010 to 2014. But you can see the kind of downward trend for all of them except for New York. Kind of sad about those bees. I'm not trying to make a depressing class today, but kind of make myself sad about these bees. Okay, so density contour plot right here, Y and X, putting it in again just like we would with the KDE plot in Seaborn. Again, then doing width and heights, marginal, and giving it the margin dig from above, title, title X and title Y. Okay. And looking at this next one here, and I'm going to do something a little bit different here. So I'm going to do my density contour plot. I'm going to update traces. So I'm going to update the things on the inside of the plot now. Okay, not just the layout. The layout is more when you're updating stuff in the background. Update traces is when you're updating things inside of the plot. Okay, so contour label show true, contour filling, contour coloring fill with the vitreous color scale. And then what I'm doing is I'm now showing the labels right here. So you can actually see how much data is inside any given one of these spots, which is just, I think, really helpful to visualize that. I don't know, really, it's something Seaborn should be having. I'll go talk to them. And getting in some of the coolest plots is the 3D scatter plot right here. So this is really cool because it lets you kind of go walking inside your data and you're able to just see things in a different way. And so I think one of the things that I didn't notice any other time in this class is really the difference right here. Average price has kind of this really lopsided value right here. Kind of just doesn't seem to really connect with the rest of the distribution. So why would average price be so different for so many values? And it looks like it's happening all in newer years. Okay, so it's kind of interesting. And so I thought what I would do is inspect this by then the color, changing the color by the year bin. You can just see now. And so I just got kind of lucky with these with the way that I made the bins. And you can see here going into this, it's kind of nice, but it's really just, it separates this by the year. And so you kind of wonder when you look at these values, 1.94 and the values are 194. 48 or 165 and 218, 217, 1 point, there's a good 4, 1.94. So there's some that are like around that. And you see these are just basically, it looks like 100 times, right? So someone instead of writing it, they change the scale that they're measuring in these. So what I'm going to do is just kind of fix this column, I guess you could say. I'm going to make this the correct scales now. So I'm going to go average price scale. I define a function. If it's this year, I'm going to be selecting two columns. So if it's the year bin 18 to 21, I'm going to multiply that value by 100, and then else I'm just going to return the value. So when I apply this across the axis 1, because I'm going to do 2 rows, so I'm going to go across the row to apply this, and it's going to iterate through the rows. Okay, and now I'm going to iterate through the rows, and then I'm going to apply that, create a scaled one. Now you can see when I plot those columns, it looks a lot more like it should. Excuse me. But now we don't see that big kind of deviation. They all look like from this, they're the same data set now because they're all the honey values, right? It shouldn't be changing so much. And then now we can start to have fun with this. So this is kind of lets you just, that's something that we didn't notice any other way, right? So it's a really valuable analysis tool that, I mean, we can just see right here the value of this, but being able to kind of walk around, and then it becomes fun as you get to walk around in this plot inside your data. Okay, so what I'm going to do is change the size of my dots in the scatter plot. I'm going to set the size maximum. I find that didn't make the biggest ones as big as possible, so this is to be able to control how big you want the biggest one to be. And it'll scale down from there. And so it just kind of shows looking at the plot and really just kind of cool. And again, really good sense of how this data is flowing. Really, the production size has also got really big as well. As we see, it kind of makes sense right here. The little dots are on the bottom here for the stock. That would make sense. Didn't really seem to affect things by the average price. Okay, the average price was the average price. They can't really control that. So you can see there's not bigger ones going to one side in terms of the production. It was what it was, right? Okay, so it's kind of interesting. And yeah, so then we can play with some more things. You can do the symbol equals the year bin. I did the same bin to make it not so busy, but you could change this to another category and there would be just a lot of categories then, right? So didn't want to make too many because you can see it gets a little bit busy already as you start to add in that, but kind of a cool effect nonetheless. Okay, looking at the 3D scatter plot here, I'm going to look at when it's New Jersey. And looking here, you can see the scatter the line plot right here. Kind of an interesting, the average prices kind of jumps around a little bit here. But the average price scaled, yield per colony, update layouts, margin dig, so nothing really good. Nothing really too different than what we've seen before. Updating this, now putting in 2 categories, New Jersey and California, and really plotting those over the time series, over time here, across the years, and really getting a sense of how how things are changing over time. Okay, so kind of interesting being able to see this and look at this in kind of like a look at this over time. Okay, so it's kind of nice to be able to look at this over time. I would say I love the 3D scatter plot a lot more though. But again, for time series analysis, it can be really kind of cool, a cool effect to show in a presentation. Okay, getting into some of our geo analysis. Okay, so here it requires things to be in a certain specific format. So what I did was I just imported a data set here from Plotly Express.data.gapminder. I'm going to get the 20 or 2007 year. Okay, just from that, kind of like a SQL query, although it's putting a string in. Okay, to get those specific rows. Okay, then we're going to get the scattered geographic right here. So looking at the state right here, the location, it just didn't work in this first one, right? So it's just the state, so it needs a very specific format, like the ISO alpha. Okay, so put ahead in the right format, hover when you're going to see the countries and stuff, where you're going to actually see the population, size, color, and then the projections natural Earth. Okay, changing this life expectancy. You really start to see kind of cool that you can see this. I think it's kind of an interesting plot to go see and inspect things. Over it's very interesting. Like I didn't realize there's such a distinct separation in Africa. I kind of thought Africa was all the same, but you can see here just by the life expectancy, the quality of life is very different in many of these more northern African countries versus these kind of southern, even down to South Africa. Only has a 49, 50-year life expectancy. I wouldn't have expected that. Okay, and that's showing me the chloroplath. So I like the 3D scatter or the geo scatter plot, but I don't think it makes as much sense as the chloroplath does. Like I think it's just kind of nicer to fill these in than just putting a dot inside. And that's why that's the only one that I talked about in the presentation. Okay, to show one last cool thing here, we can do the interactive pandas plotting. Okay, and then so what this is going to do is going to change the back end of pandas so that we can now access and use Plotly, not to the same extent, but do a lot of the same things with this. Okay, so now we're going to work with it and like not like matplotlib, we're going to work with it like Plotly. Okay, so we're going to plot hist. So you have to use the actual specific hist function, no more the general just plot function, to be able to pass in these kind of unique arguments, width and height. We're going to go margin dic. Title right inside this here, inside the update layout again, and then X and Y. Okay, so this gives you the same access to the same features. So color equals year bin, so it's going to be changing now. A very easy way to change in spot, kind of like Seaborn, but with the Plotly interactivity, right? Where you're seeing lots of these things highlighted. We could also do the marginal box, and this is the way that I use this the most. It's just so quick and easy. Now we can see our outliers are right here. When you're doing machine learning, you just have to know the outliers, the values that these are. Right? So you can see right here, oh, here's the upper fence. Okay, so I'm going to write down this number, and I'm going to truncate to this. It's just so quick and easy versus doing the actual IR calculation yourself. Okay. And you can see that doing a box plot here as well, getting the same interactivity, and you're kind of limited with what you can do, but it's nice to be able to do these, even in these simpler senses, being able to plot these here, doing the dfmean.plot.bar. So I just did the univariate, not univariate, but getting the summary statistics of each column. So univariate in the sense now, one column, one row representing the average of each column, and with height, and then changing it in the same way. Okay, so just getting the average of this one, and you can see the kind of different scales for these though. Okay, so it's kind of cool that you can do this in pandas, get some amazing interactivity from what we saw up above, but do some interesting, not too much, but some basic things in pandas as well with the Plotly edge.